Hi there, welcome to my channel. In this video, I'm going to explain about how to construct the quad tree. Let's look at the problem description. We are given an n by n matrix grid with values zeros and ones only, and we want to represent the grid with a quad tree, and we have to return the root of the quad tree that represents the grid. The quad tree is a tree data structure in which each internal node has 4 children, and in addition to that they have the value of that node, and there is a flag which indicates whether it is a leaf node or not. If the value of the cell in the grid is 1, then the value of the node will be true, otherwise it will be false. We can construct the quad tree from the 2D matrix using the following steps. If the current grid has the same value, then we have to mark that current node that represents the grid as the leaf node. So we have to mark that the isLeaf flag to true, and then the value of that node will be set with one of the cells in that grids. So if the cells in the current grid has a different value, then we have to mark that as an internal node by setting the is flag to false, and then the value of the node will be set with either true or false. And then we subdivide that current grid into 4 subgrids and then repeat that process until the grid size becomes 1. For example, here we have 4 by 4 grid, and at the root level a single node represents the entire grid, and then we divide that grid by 4 2 by 2 size subgrids. Each will be represented by one node in the quad tree, and then we divide that further into 4 subgrids with single cell in each subgrid. Let's take a look at the example 1. We have a 2 by 2 matrix. At the root level, this entire grid is represented by a single node, the root of the quad tree. Then we divide this grid into 4 subgrids with size 1. Each subgrids will be represented by a single quad tree node. For example, this cell is represented by this node. Because this is the grid of size 1, we mark that current node as the leaf node, and then we assign the value 0 because the current cell's value is 0. Then the top right cell is represented by this node, and then the value of this cell is assigned to the value of this node. Likewise, the bottom left cell will have the value 1 and the isLeaf flag is marked as 1. The bottom right cell, the isLeaf is marked as 1 and the value is set with 0 because it has value 0. So once these 4 nodes are created, these all should be linked with the parent node which represents this 2 by 2 grid. So this node's child pointers will be updated with the pointers to each node. Okay, so this node's top left is assigned with this node's pointer, and this is top right is assigned with this node pointer. Okay, so once this is done, then the final output will be the level order traversal of this quad tree. So in this case, first node will give values 0, 1. So we have 0, 1, and the second node is having a 1, 0. Here we have 1, 0. Here 1, 1, 1, 1, 1, 0. We have 1, 1, 1, 1, 1, 0. The number of rows and columns of the grid is equal to n. Okay, where n's value is 2 to the power x, where x is ranging from 0 to 6. Let's look at the approach to solve this problem. We are given a 4 by 4 grid, and this is an expected output. This is basically a level order traversal output of the quad tree that represents this grid. Okay, so this is the 4 by 4 grid. As per the problem description, the quad tree's node value is depending on the value of its children. For example, this node's value depending on all these 4 children. If all are same, then this nodes will be set with one of the nodes value and mark that as a leaf node. But they are different, then we have to divide grid into subgrids and compute recursively. So basically, to find the value of the node, we need to know the value of its children, right? So in that case, we can use the value present in the individual cells directly only in the leaf node case. Okay, all other higher level nodes or intermediate nodes are depending on its children. Okay, so in that case, we have to divide this grid into 4 subgrids repeatedly until the subgrid size is 1. Okay, so in this case, we divide this grid into 4 subgrids. Okay, 1, 2, 3, 4, and then this subgrid in turn divided into 4 subgrids. Now the grid size becomes 1. So in this case, we can directly use this value and assign to the quad tree node that represents this particular subgrid. Once this is done, then on the way back, then we have to create a node that represents this subgrid, and then depending on all the 4 subgrids value, we can assign the value of that node. Once all these 4 subgrids nodes value is determined, then we can create the root node, and based on all these 4 subgrids value, we can assign value to the root node. So basically, we are solving this bigger problem by solving this smaller problem of the same form. So we can use the divide and conquer approach, and also we can use recursion to code this solution. At each recursive call at the beginning, we create a node to represent the current grid, but we update the value after computing the subgrid's value. When we go from top to bottom, we create a nodes without assigning the actual value, but when we go back in the recursive call, at that time we populate the individual parent node's value all the way to the root. Let's take an example of this 4 subgrids. Okay, so this subgrid of size 1 and it has value 1. So we mark that as a leaf node and then assign the value. And this one is also a leaf node, but it has value 0. So we mark that as a leaf node and value 0. And here mark this node as a leaf and then assign the value 0. And the bottom right cell has value 1 and we mark that as a leaf node. So 1, 1. Okay. So once this is computed, on the way back, we check whether all the nodes are having same value. In this case, 1, 0, 0, 1. So they are not same. So in that case, we can assign any value to this node, but this node is marked as non-leaf by setting value 0. So these 3 subgrids are marked as leaf node. Okay, the reason is their subgrids all are having value 1. Okay, so we assign this value here and mark that quad tree node that represents this subgrid as a leaf node. Same for this subgrid. All are having 0. So we assign the value 0 and mark that node as leaf node. And for this subgrid, all are having value 1. So we assign the value 1 and mark that node as a leaf node. Okay. So once these 4 subgrids value is determined, in this case 1, 0, 0, 1. Okay. Then we have to update the value of this node. Okay. So in this case, we can assign any value as the value for this node. Okay, because all are not same. So we assign that value 0 and then we mark this node as non-leaf node. Okay. Then if we do the level order traversal of this, then we will be getting this output. Basically, we can solve this problem using divide and conquer approach. First, we initialize the start row, start column indexes, length variable. Okay. Then we call the search helper function with grid and the start row index and the start column index of that grid's top left cell, and then the length of that grid. In that search helper function, first we create a node with default value. Okay, so isLeaf flag is set to false, and then we check whether the length of the grid is 1. Then we mark the current node as the leaf node and return it. Otherwise, we divide grid into 4 subgrids. So basically we divide the length by 2, and then we call the search helper function for each subgrids in that 4 subgrids. So the each function return value is assigned to the top left, top right, bottom left, bottom right variable. Once we come out of these recursive calls, then we check whether all the 4 nodes are leaf node and have the same value. In that case, we can mark the current node as the leaf node and assign the top left node's value as the current node's value and return the current node. Otherwise, we assign all the 4 returned value as a children of the current node, and finally we return the current node. Let's look at the flowchart. Input for this search helper procedure is the grid, start row index, start column index, and length of the grid. Okay. First we initialize the current node with isLeaf flag as false. Next we check whether the length of the grid is 1. In that case we hit the base case. We can directly read the value in the cell and assign that to the current node's value, and then mark the current node as leaf node and then return it. Otherwise, we divide the current grid into 4 subgrids, and basically we divide the input length by 2 and we assign that to sublength variable. Then we make a recursive call to process the top left subgrid and assign the return value to top left. Then we make another recursive call with start row and start column plus sublength as the starting index of the cell, and then assign the return value to top right. Then we make another recursive call to process the bottom left subgrid and assign the return value to bottom left, and the fourth call to process bottom right subgrid and assign the return value to the bottom right pointer. Okay. Once we come back from those calls, then we check whether all turned nodes are leaf node and have the same value. If that is true, then we mark the current node as the leaf node and assign the one of the node's value as the current node's value and return. Otherwise, we assign the top left, top right, bottom left, bottom right pointers as the children of the current node, and finally we return the current node. Let's move on to coding. First I initialize the start row and start column index to 0. And then I make a call to construct helper function with grid and the start row and start column indexes and the length of the grid. Next I write the construct helper function. This takes the grid, start row index, start column index, and then the length of the grid. Returns the pointer to the node. First I create the current node with the value present in the current cell pointed by the start row index and start column index. If that is 1, then I set true, otherwise I set false as the value, and then I mark the current node as non-leaf node, so it is false, and then set null to all the children pointers. Next I check the base case where if the length of the grid is 1, then I mark the current node as the leaf node and return that current node. Otherwise, I divide the current grid into 4 subgrids. So I divide the length by 2 and assign that to sublength variable. And then I make a 4 recursive call to process the 4 subgrids. The first one is for the top left subgrid. So this one I pass the grid, start row, start column index, and the sublength as the length of the grid. Next I process the top right subgrid. So for this one I pass the start row and then start column plus length as the start column index. And then I pass the sub length as the length of the grid. Next I process the bottom left subgrid. For this I am passing start row index as start row index plus sub length and start column index as it is. Next I process the bottom right subgrid. So for this I am passing start row plus sub length and start column plus sub length as the row and column indexes of the top left cell. And sub length as the length of the subgrid. Next I check whether all the 4 nodes returned by the construct helper functions are leaf node and all are having the same value. If this condition is true, then I mark the current node as the leaf node and assign the top left subgrid node's value as the current node value, and then I mark the current node as the leaf node and return the current node. Otherwise, I assign the 4 nodes as the children of the current node. I assign the top left node as the top left child and the top right node as the top right child, and the bottom left node as the bottom left child, and the bottom right node as the bottom right child. And finally I return the current node. Next I'm going to run the test cases. All the tests passed. Next I'm going to submit this program. Cool, this program is accepted. Next I'm going to do the code walkthrough with sample input. We are given a grid of size 2 by 2 and this is an expected output, basically the level order traversal output of the quad tree. Okay, so first we initialize the start row and start column to 0. Okay, and the length is initialized with the length of the grid. So here it is 2. Okay, then we call the construct helper function. So here the start column is 0, length is 2 and the root is nil. Okay, and we call the construct helper function with start row index, start column index as 0 and the length 2, and we create the current node. So in this case the current node is, when we enter, it is initialized with 0 and 0. Okay, next we check whether the length is equal to 1. In this case it is not, so we go ahead and divide the current grid into 4 subgrids. Okay, we divide the length by 2 and assign the value to the sub length. Okay, then we make a recursive call to process all the 4 subgrids. Okay, so first we make a call to process the top left subgrid. Okay, so here the start row and start column is 0 and the length is 1. Okay, so because the length is 1, we mark the current node as the leaf node and return. So in this case the current node, when we return, the isLeaf flag is marked as true and then the current cell's values assigned to the value of the current node. Okay. Next, we make another recursive call to process the top right subgrid. So in this case, the start row is 0, start column is 1 because we are passing start column plus sub length. And then we check whether the length is 1. So in this case it is true. So we mark the current node as the leaf node and then we return current node's value as 1 and it is marked as leaf node. And third, we process the bottom left subgrid of size 1. So in this case the start row index is 1 and start column index is 0. Here we are passing start row plus sub length as the start row index in this call. Okay, that's why we are having 1 and then 0 and the length is 1. So we mark this current node as a leaf node and we assign the value of the current cell to this current node. So we have 1 comma 1 for this node. Next we process the bottom right cell. Here the start row and start column are 1 because we are calling the constructor helper function with start row plus sub length, start column plus sub length and then sub length, right? So here also the length of the grid is 1. So we mark the current node as leaf node. So that flag that is set to 1 and the current node's value is 0. So that value is assigned to the quad tree node. So we have 1 comma 0. So once all these 4 function calls are returned, we go back to the frame 1. Okay, where we check whether all the return nodes are leaf node and all are having the same value. So in this case all are leaf node but they are having different values 0, 1, 1, 0. Okay, so this condition is false. So we go ahead and update the current node's children pointers with all the return values. Okay, so top left, top right, bottom left, bottom right are assigned as the children of the current node which was created in frame 1. So these links are established on the way back to the root. Okay, so now the root node is linked with all the 4 children and we can assign any one of the value to this root node's value as per the problem description. So we marked as 0. Okay, finally the construct helper function returns back to the construct function. So here we return the root as the output. If you do the level order traversal in this tree, we have 0 0 1 0 1 1 1 1 1 0. Okay, 0 0 1 0 1 1 1 1 1 0. That is an expected output. Next I'm going to do the time and space complexity analysis for this solution. The time complexity of this procedure is order of n square. Okay, so in order to build the tree we have to process all the elements in the grid. So given the size of the grid is n, there are n square cells present in the grid. For example, the grid size is 2, then we process 4 cells. If the grid size is 4, we process 16 cells. And if the grid size are n, number of cells processed is n square. Okay, so that's why the time complexity is order of n square. Space complexity is order of log n because we are using recursion. The call stack utilizes the stack space. So the maximum height of the call stack is order of log n base 2. Okay, so that's why the space complexity is order of log n. Thanks for watching this video. Have a great day.